Hey, so in this video we're going to discuss the method of substitution and how to use it. In particular, we're going to be looking at a quadratic function where it simplifies our life to just substitute in something else or what we're looking at. Um, and that's why you would always use method of substitution, is that it does simplify it. Okay, so the method of substitution. Okay, so let's say we have this. We have 2 bracket x plus 3 squared minus 11 x plus 3 plus 15. Let's say it equals 0. So if we're looking at this, you'd have to FOIL this out, then you'd have to distribute the 2, and then you also have to distribute the 11, and then solve for x, and group like terms and all these things. So it does kind of make for a pain. So why don't we just say, let's let r equal x plus 3. So that's kind of nice. So I'm going to substitute r everywhere I have an x plus 3. So now it's 2, and I have x plus 3, so that's r, and there's 2 of them squared, minus 11 r plus 15. That equals 0. Okay, so now it looks like a function that I'm used to. Now, I can factor this, and we should factor it. So we need two things that multiply to 30 and add to negative 11. So I have 1 and 30, that's not going to work. 2 and 15, no. 3 and 10, no. 4 doesn't divide, it's not a common factor of 30. 5 and 6, that works if they're both negative. Okay? Perfect. So we're going to break that down into 5 and 6. So we have 2r squared minus 5r minus 6r plus 15. And that equals 0. We factor by grouping like terms. Not like terms, but the first two and the last two. And so, in this case, it'll be a little weird. I'm going to have to factor out a negative out of that because there's a negative here. So here, I can only factor out an r, so that kind of sucks. But that leaves me with 2r minus 5. And here, there's a negative 6, so I can factor out a negative 3. Is the greatest common factor here. And that leaves me with 2r minus 5, which equals 0. And now I have this and this are the same, so I factor that out. So then I have 2r minus 5, and the remainder is r minus 3, and that equals 0. So now I can almost solve this. I actually just have to substitute x plus 3 back in. So now this is 2x plus 3 minus 5 times x plus 3 minus 3. Okay, so now I distribute the 2, and that gives me 2x plus 6 minus 5. And then this one I don't have to distribute. There's no number to multiply in front of it. So then I have 2x, and that's plus 1. And this one is just x. So now I find my roots are x equals 0 for this one, and the other one is 2x plus 1 equals 0, which is x equals minus a half. So I've used the method of substitution to find the roots to a quadratic equation that looks quite difficult. So we can just kind of simplify our steps. We do eventually solve and substitute back in, which you should always do. If you substitute out, substitute back in. It just makes our life a lot easier.